AB Calculus First Semester Final 2020 version. This is a review of the test that my calculus students took a couple weeks ago. So we're going to go over this. This is a non-calculator test. Problem 1. The limit as n approaches infinity of 3n cubed minus 5n plus 1 over 1 minus 2n squared minus n cubed. Well, what happens is that as we approach infinity, the other terms besides the highest power term will pale in insignificance. So it's as if we can ignore the terms that aren't of the highest power. So what we're going to end up with is 3n cubed over negative n cubed, which is going to simplify to negative 3 over 1 or negative 3. And so we call this method Betsy in our class. And we're not going to even need to show any further work than that. Next, problem 2. An equation of the line tangent to the graph of y equals 2x plus 3 over 3x minus 2 at the point 1, 5 is, and we have our answer choices. The thing we need to have for the equation of the line is we need to have a point. In this case, our point is given to us as 1, 5. And also we need a slope. Now our slope in this case is not given to us, so we're going to have to find out what that is. And to find out what that is, we're going to find the first derivative of this equation here. And so y prime is equal to, what we have here is a quotient of two different functions. So in this case, our high function we're going to call 2x plus 3, and therefore the derivative of the high function is 2. And we have our low function is equal to 3x minus 2, and the derivative of our low function is 3. So to find y prime of x, it's going to be low d high, and low is going to be 3x minus 2, and d high, low d high minus high, and high is 2x plus 3 times d low, and d low is 3. It's all over low squared, so we have 3x minus 2 squared. And now we really have to simplify the numerator. Our denominator is going to require nothing. So what we have in the numerator is 2 times 3x, or 6x. And we have negative 2 times 2 is going to be minus 4. Minus, we have 3 times 2x, so it's going to be minus 6x. And minus 3 times 3, or 9, all over low squared. And simplifying out, what we have is 6x minus 6x cancel each other, so we have negative 13 over quantity 3x minus 2 squared. So now let's go ahead and substitute in 1. So I'm going to call this y prime of 1. That's going to be equal to negative 13 over, we have 3 times 1, or 3 minus 2 squared. It's going to simplify to negative 13 over 1. So that's going to be equal to our m sub t, we call this, equals negative 13. And so now we have our different answer choices, which are all in standard form. Let's go ahead and write this equation of tangent line in point slope form, which is going to be y minus y1 equals m times quantity x minus x1. In this case we have y minus 5 is equal to negative 13 x minus 1. And we have this in a standard form here. Let's go ahead and continue to simplify. Well, let's go ahead and add 5 to both sides. So I'm going to kind of work a couple steps at the same time. Y equals negative 13x, and negative 13 times negative 1 is going to be plus 13, and we're going to have plus 5 from the left, and we add 13x to both sides of the equation. We get y plus 13x is equal to 18, and so that's going to be our answer, which is answer choice B. Next, 3. If f of x equals 4x cubed minus 3x minus 1, equation line tangent to the graph at x equals 2 is, again for this we need a point, and we already know the x coordinate for our point is 2, so 2 comma something, and then our slope m sub t is equal to, we'll find that out. First, let's find our y coordinate for the point. We're going to put in f of 2 is equal to 4 times 2 cubed minus 3 times 2 minus 1, which is going to be equal to 2 cubed is 8. So what we're going to have is 4 times 8, which is 32. And then minus 6 minus 1 is equal to 25. So we have our y coordinate is 25. So we write that up here at our point. And now let's find f prime of x, which is going to be 12 x squared minus 3. And now substituting in 2 for x, f prime of 2 is going to be equal to 12 times 2 squared minus 3, which is going to be 48 minus 3, or 45. And that's our m sub t. Again, using, as we did in problem 2, point slope form, we have y minus 25 is equal to our slope 45 times quantity x minus 2. Now we're going to add 25 to both sides. So we have y is equal to 45x minus 90 plus 25, which is going to be equal to 45x minus 65. So that's going to be our answer, choice C. Next, for the absolute maximum value of fx equals x cubed minus 3 x squared plus 12 on the interval from -2 to 4 occurs at x equals question mark. We're going to do, this is going to be the extreme value theorem, and what we do for this is called a candidate test. And what are the candidates? The candidates are going to be the endpoints and the critical number. So if we have x, f of x, first thing I like to put in here is the endpoints. Well, we're going to have -2 is an endpoint, and also 4 is the other endpoint. And then also the critical numbers. Let's go ahead and find the other critical numbers first, if any. What we have here is, to find our critical numbers, we find the first derivative of our function, which is going to be 3x squared minus 6x plus 0. Derivative of 12 is 0, so we don't even need to do that. And now setting this equal to 0, 0 is equal to, our common factor here is going to be 3x times quantity x minus 2. So our other critical numbers here, we have 3x is equal to 0, so x is equal to 0. That is a critical number. And also if we set x minus 2 equal to 0, x equals 2 is another critical number. So we have 0 and 2 as further critical numbers. Now, at this point, we can actually save a little work by writing out, doing a little number line analysis and putting our critical numbers on this number line of 0 and 2. In the top, if we put f prime, at the bottom we put f, we can see what's happening. If we, using our equation here, if we take a number less than 0, we are going to have a negative times a negative, which means f prime will be positive, which means f is increasing. Well, that means that we cannot have, if we're increasing all the way up to x equals 0, we know that we can't have a absolute maximum at -2. And between 0 and 2, we will have a positive times a negative, or negative. So going down to 2, we know that can't be an absolute value, absolute maximum at 2. So we cross out 2 as well. And then finally, between 2 to 4, we're going to have a positive times a positive. So we are going to be increasing. So really all we have to do is plug in 0 and 4, because -2 and 2 are disqualified. So let's go ahead and do that. f of 0 is going to be equal to, we plug in 0 to this f of x function, we're going to get our y-intercept of 12. So that's a possibility. And now f of 4 is going to be 4 cubed minus 3 times 4 squared plus 12. And that's going to be equal to 64 minus 3 times 4 squared. That's going to be 48 plus 12. and what we get here is 64 minus 48 is going to be 16 plus 12 is 28. So 28 is our output value, meaning that we achieve our maximum, absolute maximum, where x equals 4. Now on the test that I reviewed, I had more than one student that showed this kind of work, yet picked 0 as the x value where the maximum occurred. I don't know how you do the work and find your answer to be 28 versus 12 and pick D as a correct answer. I don't understand that. I hope I'm going to find that out. 5. At x equals 3, the function given by f(x) equals this piecewise function, x squared when x is less than 3, and 6x minus 9 when x is greater than or equal to 3 is, and we have these different combinations of continuous and differentiable. Well, we do have an equal sign here, greater than or equal to, so we know that the function is going to have to be defined. And answer choice C is going to be impossible also, because to be differentiable you first have to be continuous, so that's impossible. Let's see. And so the other three possibilities, they are possible. So let's go ahead and check continuity first, which is going to be the limit as x approaches our critical number of 3 of f of x from the left side. That's f of x is equal to, I'm going to put a question mark above that, the limit as x approaches 3 from the right side of f of x, and the left side is going to be x squared, so we have x squared, and the right side we have 6x minus 9, and now we can plug in our value of 3, so we have 3 squared or 9 on the left side, and the right side we have 6 times 3 or 18 minus 9. We end up with 9 equals 9. So this is a demonstration of continuity, and so D is not a correct answer. Next, to check for differentiability, we need to find if the limit as x approaches 3 from the left side, not of f of x, but f prime of x, is equal to the limit as x approaches 3 from the right side of f prime of x. And for that, again, question mark. On the left side we have the derivative of x squared, which is 2x, and the right side we have the derivative of 6x minus 9, which is going to be 6, and now plugging in 3, we have 2 times 3 is equal to 6, 6 is equal to 6. So that checks out for both continuous and differentiable. Answer choice E. Next, 6. F of x equals square root of 2x, f prime of 2 equals. And so to take this, we're going to take the derivative of this function here. First I'm going to rewrite in calculus friendly form f of x equals 2x to the 1/2 power, and so f prime of x is equal to 1/2 of 2x to the negative 1/2 power times the derivative of the inside, which is 2, that's the chain rule, And so what we end up having here is f prime of x is equal to 1/2 times 2 over square root of 2x. And 2 over 2 will cancel each other. So now we have f prime of 2 is equal to 1 over square root of 2 times 2, which is equal to 1 over square root of 4, which equals 1/2. And therefore our correct answer is B. Next, 7. Well, what we have here is an integral, and I'm going to rewrite this integral as the integral and square root of x times x is going to be x to the 3/2 power, and then that's going to be dx plus 2x to the 1/2 power, which is what we get when we multiply this, the square root of x times 2 dx, and then that's going to be the integral of that one too. So that's what it's going to be. Now let's go ahead and use the rule of this, the power rule. That's going to be equal to x to the 5/2 divided by 5/2, which is the same as multiplying by 2/5. That's going to be plus 2 x to the 3/2 divided by 3/2, which is the same as multiplying by 2/3, and it's going to be plus the constant of integration c. So what we have here is 2/5 x to the 5/2, and then we have 2 times 2 divided by 3, so that's going to be plus 4/3 x to the 3/2 plus c, and which is going to be answer choice D. And really, in a situation like this, the fastest way to solve it is the way I did just now. But even if you don't have that option available to you, having answer choice, you could work backward from the answer choices and see if where you get your original integral at the top of problem 7. Next, 8. If limit as x approaches 3 of fx equals 7, which of the following must be true? The key thing, must. And there are a couple different ways for this to happen. One way is if we have at c, or assume at x equals 3, we can have a function that is continuous, where f is continuous at x equals 3, f is differentiable at x equals 3, and f of 3 equals 7. So if we have right here, that is one way of meeting this requirement. But there is another possibility. What if instead we had a whole where x equals 3, like this? Okay, well, in this case, this meets the requirement, the limit as x approaches 3 of fx equals 7. Well, the limit equals 7. Is f continuous at x equals 3? No, it is not in this case. Is f of x differentiable? No, it is not, because f of x is not continuous. Does f of 3 equal 7? No, it does not. And so, as far as must being true, none of these three items must be true, and therefore the answer choice is A, none. Let's go to problem 9. Given fx equals 2x squared plus 1, the instantaneous rate of change at x equals 3 is how much greater than the average rate of change between x equals negative 1 and x equals 3? Well, first of all, let's go find the instantaneous rate of change. To do that, that's going to be the first derivative, found at the first derivative. So f prime of x is equal to 4x. And then, so f prime of 2 is equal to 4 times 2, which equals, boy, if I could write down the answer, I'd be great. I said 4 times 2. 4 times 3 equals 12. Okay, so that is our instantaneous rate of change. Now the average rate of change. Average rate of change equals f of b minus f of a over b minus a. And so we'll say a is equal to negative 1, b is equal to 2. And so let's go ahead and plug in f of b. It's going to be f of 2 is equal to 2 times 2 squared plus 1. And 2 times 2 squared, that's going to be 9. Plus 1 is 9. F of negative 1 is equal to 2 times negative 1 squared plus 1, which equals 2 times 1 plus 3, or let's see, it's going to be 2 plus, it's going to be 3. So what we have is our average rate of change is going to be f of b minus f of a over b minus a, which is going to be 6 over 3, which equals 2. So how much greater? Well, what we have is, how much greater we're going to have is I rock minus a rock is going to be how much greater. So 12 minus 2 is equal to 10. So therefore your instantaneous rate of change is 10 units greater than your average rate of change, and therefore our answer choice is D. Next, 10. The cost producing X number of bicycles is given by C of X equals X cubed minus 48 over X. Now, what is the minimum cost? This is another extreme value theorem, and for that we can put a candidate test in place. And what are the candidates going to be? Well, we're going to have X in C of X. Well, our candidates are going to be 1 and 10 plus any intervening critical numbers. Let's go find our critical numbers here. Well, let's say X, we're going to have C of X is equal to X cubed and plus 48 over X, so it's going to be plus 48 X to the negative 1 power. So C prime of X is equal to 3 X squared, and then we have negative 1 times 48, so it's going to be minus 48 x to the negative 2 power. And now we find the critical numbers by setting this first derivative equal to 0. So we put 0 equals 3x squared minus 48 over x squared. So we can solve this by getting a common factor if we want to, but I think it might be easier just to add 48 over x squared to both sides of the equation. So we have 48 over x squared is equal to 3x squared. And I'm just going to kind of work to the right here. And if we divide both of the numerators by 3, we're going to get 16 over x squared equals x squared. And cross multiplying the x squared, we're going to get 16. We'll get x to the 4th power is equal to 16. And taking the 4th root of both sides of the equation, we're going to have x is going to be equal to plus or minus 2. And between x equals 1 and x equals 10, the negative 2 is not in that interval, so we're going to put 2 right here. So now we have our possible input values for this. So let's just go ahead and try them. We can try them pretty easily here. We'll try the endpoints first. C of 1 is equal to 1 cubed plus 48 over 1, which equals 49. Okay, so that is that's a possible minimum cost, which means any number bigger than 49 is excluded already. So D and E are excluded. Now let's try C of 10, our other endpoint. For this we get 10 cubed, or 1,000, plus, let's see, we would get 48 divided by 10, or it would be 4.8. And so that's not going to be it either. That's going to be a really huge number. So now we're going to have to try C of 2. That's going to be equal to 2 cubed plus 48 over 2, which equals 8, plus 24, which equals 32. So 32 is our correct minimum cost. Answer choice A. Next, the graph of y equals fx on the closed interval from negative 3 to 7 has the following endpoints. We're given endpoints from negative 3, 4 and 7, 1. F of x is continuous on the closed interval and differentiable on the open interval. There exists an x value c between negative 3 and 7 such that f prime of c equals something. What we're looking for is the answer is going to be found in our average rate of change. So again, we have negative 3 is going to be A, 7 is going to be B. So let's find that average rate of change. That's going to be our answer. So A rock equals f of B minus f of A over B minus A. And for this, 1 is going to be f of B. So here's our B. It's going to be our B right there. This can be our A. So we have negative 3, and f is A, and f of A is 4. Let's put the b first. So we have f of b, which is 1, 1 minus 3 over b minus a is going to be 7 minus negative 3. And for that, we get, it's going to be 1 minus negative 3 as we go here. I'm getting it mixed up here. Okay, we have 1 minus 4, excuse me. I knew something was wrong there. F of b minus f of a, so 1 minus 4 over 7 minus negative 3. That looks better. So here we get negative 3 over 10, which is answer choice B. I saw what I saw here on the test was, unfortunately, some people picked this one here, negative 10 over 3. It is not that at all. Next problem, 12. The function f is defined in the interval negative 5 to 5, and its graph is shown to the right, which the following statements are true. So we usually check these things one at a time. Let me go ahead and magnify that somewhat. So 1, the limit as x approaches 1 of fx equals negative 1. So let's go to x equals 1. So the limit as x approaches 1, which would be the limit from the left side and the right side, is not negative 1. It's going to be negative 2. So that is not a correct choice. So now we know that A is not right. And what else is not right? Oops, my pen is going wacky on me. I don't know how that happened. Yes, so that is not right. Any answer choice with A is not right. With 1 is not right. So next, let's look at the limit as h approaches 0 of f of 2 plus h minus f of 2 over h equals 2. This is the definition of the derivative. So we're looking for the slope at x equals 2 being equal to 2. So we go ahead and look at this, and I say, well, at x equals 2, what is the slope going to be? What we have is the slope is going to be the same for all of this line segment, so up 2 over 1, up 2 over 1. So yes, that is correct. And so so again, B and D are still possible. Next, the limit as x approaches negative 1 from the right. Let me make sure I have that. I'm reading that right. 1 from the positive side. Okay, that's going to be equals negative 1 from the positive side, so that's going to be 1 is equal to f of negative 3. Well, f of negative 3 is also equal to 1, so the limit from the right is 1, and also f of negative 3 is 1, so they look like they're the same. So answer choice D is correct, 2 and 3. Now, in the numbering system here, I skipped numbers 13 and 14 because in the test that I had available, we weren't quite ready to test problems 13 and 14. So let's go to this table. Use the table below to answer problems 15 through 18. Particle's velocity is given in feet per minute in the table. What is the minimum number of times the speed of the particle had to be exactly 5 feet per minute? And then justify. Well, this is something that the speed is equal to absolute value of velocity. Okay, so we have to look at that. So this tests the intermediate value theorem. We know the speed has to be exactly 5, somewhere between t equals 0 and t equals 2, because we can't get from 4 to 8 without passing through 5. So that's once. And then also we can't go from 9 down to 2 without passing through 5. So that's twice. But also what happens is we also have to pass through 5 again, a speed of 5. Why is that? Because between 2 and -7 we have to go through -5. And the absolute value of -5 is 5. And finally, between -7 and 1, we have to go through -5 again. So our answer is going to be 4 times. And our justification, according to IVT, intermediate value theorem, and just to give one example, f of 5 is going to be greater than v of 0, but less than v of 2. Okay, and so that's going to be correct. And also 5 is going to be less than v of 5, but greater than v of 7. And then we could also say for this absolute value of -5 is going to be greater than v of 7, but less than v of 10. And finally, absolute value of -5 is going to be greater than v of 10, it's going to be less than v of 10, but greater than v of 12. So that's how we would get that. So let's go to, actually we can make this absolute value too. You can see what we're doing here. Okay. Use the data in the table to estimate the acceleration of the particle at t equals 4 minutes. Show correct units. Well, the correct units are going to be, we have feet per minute, and so we're going to have our correct units are going to be feet per second squared. That's the correct units already. And how many do we have? We're going to have at t equals 4 minutes. Well, we don't have exactly 4, so we have to use these two here. So what we have here is estimate of acceleration equals the average rate of change of velocity. And that's going to be equal to, in this case, we're going to have 9 minus 8 over 5 minus 2, which is going to be equal to 1/3 feet per second squared, and those are the units. 1/3 feet per second squared. What is the average change in velocity on the interval from 0 to 12? Show correct units. Well, in this case, we're going to have 1 minus 4 over 12 minus 0. And that's going to be -3 over 12, which equals -1/4. And that's going to be feet per minute squared. Now, I had the units not exactly right over here, did I? And choice B, it's going to be feet per minute squared. And I had a student who did point out in 18, that's going to be minute squared. Is there a time when the particle's acceleration had to be exactly -0.25 feet per minute squared? Yes. And really, if you did problem 17 properly, you would have noticed, I hope, that -0.25 is exactly the same as number 17. And so the answer to this question is yes. According to the mean value theorem, there had to be at least one time at least once when A of t, we'll call this A of t, is exactly equal to -0.25 feet per minute squared. Okay, next. Okay, again 19. Students are ready for you, so we're going to skip right to number 20. A particle moves along the x-axis position for x is greater than or equal to 0 as determined by the function fx equals x cubed minus 9x squared plus 24x for what values of x is the particle at rest. Now to do that, we're going to find the first derivative and set that first derivative equal to 0, and that will give us our answer. F prime of x is equal to 3x squared minus 18x plus 24, and set this first derivative equal to 0. So 0 equals 3 times 20x squared minus 6x plus 8. And dividing by 3, we have 0 is equal to the factored form of x squared minus 6x plus 8, which is going to be x minus x minus, and we're going to have 2 and 4. So for what values of x the particle at rest? we set each of these factors equal to 0, we will say when x equals 2, and also when x is equal to 4. I was looking to put units there, but they don't give the units exactly, so this is going to be our best and only answer to this. Next, 21. What is the integral from 5 to 1 of 3 dx? Now, this is a definite integral, and you can look at it. We haven't really gone into definite integrals, fundamental theorem of calculus yet. But at the beginning of the year, we sort of conceptually saw this was, so if we have y is equal to 3 between 1 and x equals 5, we have this area here, which is going to be a rectangle that is 3 units high and 4 units wide. So the area is going to be 12, but the integral from 5 to 1 is going to make this area negative, so our answer to this question is going to be negative 12. So that is that one. And then the last one we have is this one. A ball thrown in the air is acceleration given by the function a of t equals negative 9.8 meters per second squared. The ball's velocity at t equals 1 second is 35 meters per second, and its position is 80 meters from the ground level when t equals 1 is a function for the position of the ball for t is greater than or equal to 0. We make use of is that velocity v of t is equal to the integral of a of t dt. And so in this case what we have here is the integral of negative 9.8 dt, which equals negative 9.8 t plus c. And so now we can substitute in here and say, okay, 35 equals negative 9.8 times 1 plus c. So if we add 9.8 to this, we get c is equal to 44.8. And so now substituting back in, our particular solution is v of t is equal to negative 9.8 t plus 44.8. And that's going to be meters per second. And next for position is going to be x of t is equal to the integral of v of t dt, which is going to be equal to the integral of negative 9.8 t plus 44.8. It's going to be dt. And just working that out, x of t is equal to, we have negative 9.8 t squared divided by 2 plus 44.8 t plus c. And I'm going to bring this up here to the right. And what we have here is x of t is equal to negative 4.9 t squared plus 44.8 t plus c, our constant of integration. So now we're going to go ahead and plug in this 0.1 comma 80. So 80 is equal to negative 4.9 times 1 squared plus 44.8 times 1 plus c. And what we get here is 80 is equal to negative 4.9 plus 44.8 plus c. And so 80 is equal to negative 4.9 plus 44.8. That's going to be 39.9. And now if we subtract 39.9 from both sides, this equation c is going to be equal to 40.1. So that is the solution for, that is our particular solution. So x of t is equal to negative 4.9 t squared plus 44.8 t plus 40.1. And this is going to be in meters. At any given time. So that's going to be our answer to problem 22, and that's our test. I hope this has been helpful to you. Good luck, and thanks for viewing.